This Week in Science is here for our weekly podcast broadcast. Are you ready to go, Mr. Safety Glasses?
Can never be too safe.
That's fantastic. I would like everyone to be safe about how they approach this show, and so know that this is a live show. It has not been edited at any point in time until it is edited and then becomes a podcast. So if you want the edited version, you should subscribe to the podcast. But right now, we're going to talk about science. We're going to do the show in its entirety. You're here. Thank you for being here. So, yeah, Wednesdays, 8 p.m. Pacific time, everybody. YouTube, Twitch, and Facebook. We ready?
Oh, and don't forget the second show, which is 5 a.m. Central European time on Thursdays.
That's where Justin is. 5 p.m. on Thursday. A.M. 5 a.m.
A.M.
European time. Central
European time.
Central European. So many time zones. Okay. One of these years, we have to have a conversation with somebody about why. Why do we have to have all the time zones?
Oh, I can tell you right now. It's because of plate tectonics and the planet being round.
Oh.
Spherical even.
Makes absolute sense. Time is a construct, everyone.
Orbiting.
Don't fall into it.
Don't fall out of time either.
Don't fall out of it either.
Oh, that gets very dangerous.
All right. Levels good, everybody. You like what you hear? We're all happy. Ping across the meridian. Yes, Schnago. We are live. Yay, Identity 4. We're doing this show thing. We are. Everybody. Yes, put Justin in low Earth orbit. That would be perfect. All right. We're going to start this show now. Thank you, everyone, for joining us. And it is go time, launching in 3, 2, 1. This is TWIS. This Week in Science, episode number 967, recorded on Wednesday, April 17th, 2024. Put more science in video games. We'll get the gamers playing the game. I'm Dr. Kiki, and tonight on the show, we will fill your heads with black holes, bright bursts, and space boulders. Watch out! But first...
Disclaimer. Science. That thing that some people do and everyone else benefits from. Science is a method of capturing and organizing knowledge gained through observation and experimentation. Its results are testable, repeatable, measurable, and predictive. It starts with a question, an idea that scratches at some past observation, some previously captured knowledge, and asks, why, how often? A hypothesis is formed. Maybe this interaction is involved, maybe that gene, maybe it only happens under this condition. An experiment is then designed, limiting the interaction, deleting the gene perhaps, moving a suspected cause. Observations are made, data is collected, unbiased analysis is applied, all to prove the hypothesis wrong or capture some new knowledge. The process repeats over and over again, advancing our understanding of everything in iterations, one study at a time, all so that we may enjoy This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. This week in science. What's happening this week in science?
Good science to you, Kiki.
And a good science to you too, Justin, and everyone else out there. Welcome to another episode of This Week in Science. We're so glad to have you here tonight, today, morning, wherever and whenever you are. I'm going to do a quick little check on the audio right now because while you were doing the intro, I switched it to automatic mic adjustment through StreamYard. So if you can do a little like, hey-oh, hey-oh, and if everyone can be like, yeah, that's great, it's fine. Or if I need to just get rid of that and let it be, let me know.
Hey-oh, everybody. Mic check, 1, 2, 3.
Do I need to turn it back to where it was before? Or do I leave it as is? Is happy? Go back to where it was? Audio sounds good, says John Hogan. Schnago is typing. He has many typings with his fingers. It has happened. Oh, Justin could be louder.
I don't know if that's
when
possible.
has anyone said that?
That's something I've never heard before. Thank you, Fada.
Yeah, never trust auto levels. I agree. Okay, yeah, okay. Editing mic settings. Thank you, Rachel. No automatic adjusting of the mic volume. Say hello, Justin.
Hello, Justin.
Yes. Hello, Justin.
Yeah, if I'm not coming across as loud, it's time to get your ears checked.
There we go. Okay, I'm a happy person now. There we go. Happy, happy, happy. Look at that. I don't know what that little piece of cow lick is doing. When have you been hanging out with the Danish cows? Okay.
Not that many of them. They're hard to find.
There's so much Gouda cheese coming from there, though. I don't understand.
Is there?
Did I just say that? I did. Okay, it's time for science, everybody. Let's get into this show. Coming back from that little technical break that hopefully will be edited out. We have a great show ahead, and we are so glad that you are joining us tonight. On this week's show, I have all sorts of science news. I have stories about aggressive bonobos. What? What kind of aggressive? I don't know. Bacterial vampires. They want to suck your blood. Space boulders. No. Supernova questions, because you always have questions about supernovas, evolution, and video games. What do you have, Justin?
Yeah, I've got a little of that in the mix too. I've got black holes that have a black hole that has maybe answered a supernova-y question.
Fantastic. Okay.
Yeah. I got a little bit of human evolution and the importance of wood in the ancient world. You know, you got the Stone Age and you jump right over to get into the Iron Age at some point. Nobody ever talks about the Wood Age.
Because the Wood Age is the stuff that didn't stick around.
Yeah, we don't have a lot of good examples.
Doesn't fossilize, right? It's like, that's all this stuff that it's like, was it a stick or was it a tool? How do you tell the difference? So let's get into those questions. Yeah? Is that what we will look into?
Yeah, exactly.
Questions like these and more on the 5 o'clock news. No, right now. We're going to start the show right now. Okay. Everyone, if you're interested in following the show on a regular basis, make sure that you catch us live on Facebook, YouTube, and Twitch, 8 p.m. Pacific time on Wednesdays. And it is 5 a.m. on Central European time. For those of you who are in the Central Europe, that is the time that it is over there. And that's Thursday morning, not Wednesday night. It is different. We also have a podcast. You can find us all places that podcasts are found. Not all of them, but a lot of them, like the big ones. Unfortunately, not Google Podcasts anymore because that's not a thing, but I guess on YouTube. So that's there now.
Huh?
Just look for This Week in Science. I mean, honestly, wherever you go, just look for This Week in Science. If we're there, you will find us. TWIS is the acronym.
I have a question. If
I know. TWIS.org. It's our website. Yeah.
Didn't they already find us?
No, but they have. Some people don't subscribe. They just are here. So I want them to subscribe so they can get us, and then the notifications, and then they can get their friends to subscribe. This is the reminder. It's time. Share, because we share the science. Yes?
Yeah.
Yeah. Okay. Let's jump right in. To start this show off, we're going to get out there with a big, bright burst. The last couple of weeks, there has been some news on the science, the research looking into the brightest gamma ray burst ever recorded. GRB 221009A was recorded in October 2022, and it has been dubbed by researchers, because researchers love acronyms and playing off of pop culture. Sorry, everybody. There are people, too. It's been dubbed the boat. Instead of the goat, it's the boat. Brightest of all time. And according to one of the researchers, this is like a 1 in 10,000 year kind of gamma ray burst brightness. It was like somebody took a spotlight and like with the theater lights, and they like tightened it down and tightened, and they shined it right at our planet, and it was like, and we were like, oh my gosh, that's amazing, and we've never seen anything like it. And researchers were all over themselves trying to figure out what caused it. Was it a regular supernova? Was it a different kind of supernova? Like, what was it? Something that is unusual? And so the researchers are like, okay, now we got to look at it, but we can't look at it because it takes a long time for all of the light and the energy from that big supernova to get out of the way. So we can actually start to look at the leftover remnants of the giant explosion. It's like when there's all the smoke around the wreckage of a race car and you can't actually get to see what the race car actually looks like or if the person inside of it is okay until the wind blows the smoke away.
Secret knowledge, Kiki's a big NASCAR fan.
Totally.
Why she's always bringing the NASCAR reference.
You can count on me to bring in NASCAR. Sideline, I really, really did love whatever that movie was, Porsche versus what was it? It was really good. It was Christian Bale and Matt Damon. Really good. Liked it. Anyway, car movie. Really enjoyable.
Ford Ferrari? Was that the?
That's the one. Ferrari. Ford versus Ferrari. Thank you. Really enjoyed it. Like they drove cars. They were fast. There were crashes. This thing. It's okay. Okay. So when we don't have a crash, but it's just an explosion, right? You have the collapse of a star and then the resulting expulsion of all the material that is left over from that collapse of a star. This is a supernova. And we don't often get to look at them taking place, but we have this hypothesis that's been driving a lot of our ideas about the formation of the universe and the heavier elements within it, which is that supernovas are those events that allow elements to come together in a neutron, in a way that produces enough neutrons that they are smushed together and end up having to create other elements, protons and like things get smushed together. And so you can get heavier elements than iron. So you've got hydrogen, helium, and, up until about iron. But then past iron, it gets very, very sparse. And it has to be certain events that take place at high enough energies to create the pressure, to create the number of particles that would be within the probability realm of getting smushed together to allow for heavier elements to actually be formed. And so they went, oh my gosh, biggest gamma ray burst ever seen. So we are going to take the James Webb Space Telescope because it's 2002 and the James Webb Space Telescope it's going to be useful and we're going to take advantage of it and we're going to look at this, but not right away because it's still really bright. It's like looking at somebody shining a flashlight or headlights in your eyes. And so they had to wait 6 months until they could actually start picking out the light signatures that are indicative of different elements. And so that is something that is, we've talked about it before in the show, the way that astronomers, astrophysicists, and others look at stars, we can see different light signatures. And the light signatures tell us a story about the composition of those stars, or in this case, the supernova event. And they were expecting to see all sorts of heavy elements because biggest gamma ray burst of all time. Oh my gosh. It had to be an extra special big supernova, something bigger. But apparently it wasn't. They got all of the same signatures that come along with a completely normal supernova. Except what they think is that this particular star was spinning. It was like a spinning star. Massive enough to go supernova, but it was special in that it was spinning. And so they think that maybe there was something about the spinning that could have focused the gamma ray bursts out of either pole of
we would have been
the actual supernova.
at a polar orientation to it for that. Yeah.
Yeah, so you have like the supernova, it collapses in, and then it goes out. But you also have the bursts of energy that kind of come out along the central lines, north-south pole of the magnetic fields that are produced, which is usually a very polar event. And so we just were in the line of fire for that particular burst. And so the brightness of it, they think may have been very specialized because of the whirling, rotating of the star before it went supernova. But they don't know for sure. It could also be that the area of space where this star went supernova, it's been doing lots of star birthing and, doing lots of stuff. And a lot of the stars that they're seeing currently are not heavy element stars. So there's not a lot of the stuff around there that could possibly like push things over the edge for heavy element production. But again, this is a question. This big question is, where does platinum come from? Where does gold come from? I mean, the only time we've seen a big thing occur that would have led to this kind of heavy element production was when the LIGO, the interferometer, the LIGO Virgo array, they saw two neutron stars merge. And so it was in that merging of neutron stars, which is a lot of density and a lot of matter. It was a big event that led to the signatures for heavy particles, but nothing else. So they're like, this is a big question. They're like, woohoo! Brightest of all time, except, okay, now we have lots of questions because things didn't work out the way that we thought that they would, which I think is the coolest.
Yeah, that's pretty wild. So I'm going to go ahead and just jump into the next story because
go right ahead.
It might try to answer some of those questions.
Maybe.
Yeah.
Yeah.
So this is astronomers have discovered the Milky Way's largest stellar mass black hole. This was published earlier this week in the Journal of Astronomy and Astrophysics. I believe this is a European Space Agency arrays of large telescope arrays that we're looking out into space, and this is the Gaia project also that's out there looking for these things. They found something kind of weird, and in drilling down on what that was so strange about a star that didn't seem to be behaving correctly, they discovered the largest stellar mass black hole we have ever found in the Milky Way. It is also the second closest black hole to our solar system, a mere 2,000 light years away. The black hole is called Gaia BH3. It weighs in at 33 solar masses, which is, if I'm doing my math right, 33 times the size of our sun.
Really? Yeah. You're right.
Which is pretty good for a collapsed star. Because, this has gone supernova. It's ejected a bunch of energy. It spent a whole lot of time burning out as a star. So, I guess that would mean that in its lifetime, it was probably more than 33 solar masses. That would be the guess I would make. Though a black hole can grow to be much larger, depending on how they are fed as a black hole. Sagittarius A, this is the supermassive black hole at the center of our Milky Way galaxy, is well over 4 million solar masses. So it's at the center of the galaxy, and it's been eating the entire time I think our galaxy has existed. It's the thing our galaxy is spinning around. 4 million plus stars condensed into a black hole. So the discovery of this BH3 black hole was made possible by a wayward star, an old star with a bit too much of a wandering wobble to it. So it showed up in the data as sort of an anomaly as they were trying to map the stars. Taking a closer look, it was revealed that it was in fact orbiting a black hole. Now, the super interesting part is that 33 solar masses, it's big for a collapsed star. Biggest one we've seen in the Milky Way so far, but we've only spotted them in this range before in other galaxies. One of the theories about how they are formed is due to the star's makeup, with metal-rich stars tending to actually lose a lot of mass during their lifetime. They sort of eject more energy, and when they go supernova, they also expend a lot of energy and particles, and they get smaller. So metal-poor stars tend to lose a lot less mass during their lifetime, which may allow them to become larger black holes. So the companion star, which could have been a binary star partner to the star that formed the black hole, they may have already been in orbit around each other, and then one could have even been leeching off of the other to some degree. But one of them got too big, too old, and collapsed. If this is a binary star, binary stars often have very similar compositions to each other. They formed out of the same space dust. Their makeup tends to be the same, either metal rich or metal poor. They tend to be the same. So they took a look at the star by the light signature, and they found it is metal poor in content, as predicted based on what the black hole composition would have been to have formed such a large supermassive black hole. So it's kind of interesting because it kind of ties into what the story we were talking about there a moment ago.
Totally, which is part of why I put it at the top together. We get spacey.
If these metal poor stars are allowed to maintain so much mass, that might explain the larger supernova. With the large gamma burst that we're seeing, it would sort of seem to be fitting for that, depending on how many solar masses. I think the smallest black hole forming solar mass is 8 to 10, somewhere in that range. That's like the low end scale.
So this is like, when they go supernova like that, it's usually can form a neutron star or a black hole after, but
our sun won't. Our poor little sun.
Yeah, depends on the mass.
Small.
Yeah,
too small.
You got to be a certain mass to collapse on yourself.
Yeah.
But I think it's fascinating that it's like the metal type, or what other type of of star that
I guess
the predominant composition of the star could influence how the mass works and how the supernova goes forward.
Yeah, the heavier elements.
It's a huge question.
Tend to eject more, so they're in a way less likely to form a black hole.
Right.
So it's going to be the metal poor ones who have the higher chance.
But how do you get the metal? How do you get the metal to make the metal?
From supernova.
Right. Tautological kind
of smaller stars, I suppose.
I guess, yeah. But then, the whole thing has to come full circle, and at some point, you have to have something big enough to create the heavier metals to get to the point where you can have an area of space that has a lot of heavy metals, and it can't all be neutron star mergers. And if it's not coming from the supernovas, even one with a bright gamma ray burst, where is it coming from? Because it's always been like, oh, where are they? They're going to come from these supernovas of the big stars. So we can't look at gamma ray bursts as a necessary indicator of how massive a star is before it goes supernova. But there's different types, all sorts of stuff. I love this story too, though. It's like, this is the previous story I talked about was taking place in near Sagitta, about 2 odd million miles away. So very, very far away from Earth, 2.4 billion light years away, not miles. We're spacefarers now. 2.4 billion light years near
Billion
Sagittarius.
light years. So this is a far off
The gamma ray burst came from far away, in the
wow.
galaxy far, far away. But the one you're talking about, which is the 33 solar mass black hole, is within the Milky Way galaxy and is
2,000 light years. It's the second closest black hole
but it's not
to our
Sagittarius
solar
A,
system.
which is
No,
400
no,
or
no,
so.
no, nowhere near. It's there's one black hole that's closer to us, but it's much, much smaller.
Yeah.
I think it's 8 to 10, somewhere in those ranges. It's one of the smaller end. This is the largest one we found, and this is I have distinctions like Sagittarius A is supermassive black hole, like that's a whole category, and then a stellar mass is one that's like it's just a collapsed star that formed a black hole. It's not a star eater itself yet, or a galaxy eater.
Galaxy eater, yeah.
You know,
no, nothing
they
like
get
that.
they get pretty big. Like the scale of, just in case nobody is already looked into this, the scale of the universe is amazingly big, mind-bogglingly, like
So much bigger.
magnitudinally large things are running around out
And
there.
I think even when you say mind-bogglingly, it is still understating the immensity.
The scale upon which we are operating in a solar system is like, it's a teeny tiny little solar system with a itty bitty little star. Like there's a lot of big monsters out there. So
there's so
the
many.
thing that that's wild about this. Okay, so it's the closest one, or second closest one of these, and it's bigger than any that we found in our entire Milky Way before for these stellar mass, and yet we didn't observe it. We couldn't observe it. It took its old companion star getting caught having a strange motion for us to even look deeper to investigate. So these black holes could be everywhere.
So
it could be all over the place.
Yeah. I mean, that's partially like one of the interesting aspects of the gravitational wave research is that when they are able to really hear that universal ocean, right? The waves and the ripples that are created by small black hole mergers, medium-sized black hole mergers, big black hole mergers, neutron star mergers, all the things merging and creating a cacophony. And what are all the sounds that can inform us about where things are, how many of them, since they're merging at this kind of a rate that we can see, what does that mean for how many of them there might be and where they might be, more or less? You know, certain areas that might have more of them or fewer of them. But
yeah, this Gaia project, by the way, that this discovery comes from, isn't actually meant to release its findings for like another year.
Yeah, so we'll be back in this again.
This one item, they're like, oh, we're going to mention this now. This is too cool.
This is super cool. And there's so many people involved on it. I love this preprint PDF that they've got available for the astronomy and astrophysics manuscript that's going out right now, or that is out as a letter to the editor. It's just this list of names of people who were part of this work.
Yeah, science is a collaboration. It's very, very rare.
Yeah.
I mean, a lot of, like, there's aspects of the lone scientist in the lab working to find the answer to a thing, which is may take place from time to time. But even then, there's a list even longer than that of their predecessors whose work they're building off of. But yeah, it's a very technical field. They need people to go onto a mountain in Chile and stay up all night looking at the stars.
Atacama Desert? Yeah, no, not doing that anymore. Maybe other places.
Takes people all over the world now collaborating.
It really, really does.
To get this data.
And in space now, apparently, too. Not just robots and telescopes. People in space. Okay, new study. Let's go to people. not space. We're going to the spaces in people and the history of our evolution. And really, not just people, all of everything since bilaterally symmetric organisms evolved. Okay, so let's go back in time to a time
Bilateral
before.
the
Yes.
symmetric.
So not starfish or tube worms or sea cucumbers. Those are that are radially symmetric. We're talking about bilaterally symmetric organisms that can be split but down the middle. We have a top, a bottom, a front, and a back. Right? We are, as vertebrates, our vertebrae, our spinal cord, or the notochord in some organisms allows that bilateral distinction. It's a huge adaptation that changed the body plan for life on Earth. No more sponges. We're going to have things with legs. We're going to have things that might have wings. We're going to have things that are going to crawl. We're going to do it differently. And so complex life needed that to happen. So if you go back in time, 700 million years ago, it was a weirdo. And that weirdo is the last common ancestor that all of the insects and vertebrates on the planet share in common. That organism had a lot of genes that have been conserved throughout evolution in all of these different organisms. But somehow along the way, Mother Nature and the genes were like, no, we're going to play. We're going to do manipulations. We're going to do different stuff. What are we going to do and how we're going to do it? And so these researchers that just published their study in Nature, Ecology, and Evolution, that's evolution of tissue-specific expression of ancestral genes across vertebrates and insects. They looked at a data set that covers the transcriptome. So not just the genome, but the transcript, which are the instructions copied from the genome that basically go into action to make things work within cells and different tissues in the body. This data set covered 8 different tissue types across 20 bilaterally symmetric, or what they call bilaterian species. I don't know. Maybe that's what I'm going to... I don't know. What what do you claim? Bilaterian. Yes, that's what I am. I'm a bilaterian from this point forward. Well, I've been for a long time. But anyway, they did a phylogeny analysis trying to figure out what changed along the path of like all these different organisms branching out and doing things differently to become different species from that first weirdo 700 million years ago. And they found at one point in time, it's like the whole genome was like, we're just going to copy and double. And it was after that doubling of the genome that the cells within different tissues were like, oh, I've got one good copy, and then I've got a copy I can play with. Mm-hmm. And so different tissue types took the second copy of the original genome and were like, no, we're going to put a mutation here, we're going to put a mutation here. So even though all bilaterally symmetric organisms, going back to that first weirdo, have all sorts of conserved genes, things that are really, really common, things that make us have bilateralism, that allow us to have different limbs and our gut system. And also, there's a lot of conserved genes that don't change for the development and for body plan and all these things. And that's why we can look into these relatedness kind of genes when we study this stuff. But what happened to make it different were the copies. And so different tissues, according to this study, their hypothesis now moving forward is that because of the copying and the doubling of different genetic segments and different chromosomes, different tissues were able to play. And when those different tissues were able to play, they came up with all the variety of life that has led to where we are today. So I find, to me, this is a very exciting and interesting realization that it's the evolution of tissue specificity that really came about because of gene duplication. And without that, we wouldn't have, any of the special, different, unique variety of creatures that we have on the planet today.
Yeah. And it seems like there's conservation of the first copy.
Yeah.
It's somehow protected from mutation, or is deleterious if it has the mutation.
Right. Where it's okay if you
And then
mess
the other
this up,
copy,
then yeah.
I mean, don't rely on so much. And so we're free to let our mutant flag fly.
Yes. We're all mutants.
Yeah.
Welcome to the mutant planet. Da-da-da. Thank you for making extra copies. We like it for our variety. Yeah. So I really appreciate this study and the insights that they came to from the work that they did. But let's move forward. You would like to talk about wood?
Well, we're going to talk about wood, but I'm going to go ahead and jump into a little bit of evolution as well here instead.
Okay, cool. Let's do that.
So this is something I'm trying to kind of get my head around, because it talks about human evolution as being weird.
What else is
which
new?
is fine.
Yes.
That's okay.
Yeah.
But according to this, it says competition between species played a major role in the rise and fall of hominids, and produced a bizarre evolutionary pattern for the Homo lineage, according to this new University of Cambridge study that revises the start and end dates for many of our early ancestors. Now, this part is, I don't know if it's a revision because it doesn't really give us the when our earliest ancestors began and ended. Although it does clarify something that's always sort of been obvious, I think, at least to me, people studying these things, which is that the start and end dates of human species have been artificial. And we know well now that even though you go, well, this form became before this form, which came before this form, we also find evidence that those previous forms survived well into the existence of the other form. And we're now much more aware with further discoveries of the sort of braided stream effect, where you have these disparate evolved humans who were recombining with older forms and other forms throughout our evolution that may have also accelerated. But it's conventionally, they say, climate is held responsible for the emergence and extinction of hominid species. So when there's a successful hominin that disappears, we usually say, hey, there must have been a major climate shift that took place that killed them off. In most vertebrates, however, according to this, interspecies competition is known to play an important role. So species competition leading to the extinction of one species and another. And I guess it's not, we might say that that's even plausible under the human form, as the current modern human seems to fit that mold. As we show up, there are somewhere around 7 other hominins on the planet. 7 versions of human, different species of human on the planet when we sort of emerge and begin calling ourselves current modern humans, despite the fact that we had all these other humans around. They're like, well, wait a sec, aren't we also the current modern humans? And we're like, yeah, for now.
We like to be modern, but maybe we'll be ancient eventually. I don't know.
So in a way, though, we did outcompete them. We followed the model, it looks like, at the end, that most vertebrates follow. But throughout the history, what this is saying is that this speciation across 5 million years of human evolution, competition fostered more speciation, and instead of the opposite. So interestingly, they say they've only also seen this this pattern seen in a form of island beetle somewhere on the planet. So
That's fascinating.
we're not the only ones. There's also some island beetles somewhere that also seem to be having this.
So the question is, what is special about those island beetles, and what do we share in common in terms of our use of ecosystems, habitats, and our ability to either collaborate and or compete? So is it that these island beetles, like the hominins, are able to, okay, we'll go someplace else. We'll go follow the food and do a different thing this way, and you guys stay here. That's okay. We'll go do this thing. And is that the adaptability is that what makes the difference?
So that's a great question, and I don't know that it's quite answered here.
Yeah. I mean, they couldn't necessarily answer it, but they're coming up with this new view, right? Of looking at it in terms of, hey, look, everybody, let's look at it in this time frame instead of the way that you might have been. There's a lot of overlap.
So here's what they're saying. So it's saying that some species are thought to have evolved through anagenesis, when one slowly turns into another, but the lineage doesn't split. It's sort of like a budding new branch over and over again. This is why several more hominin species than previously assumed were coexisting, possibly competing. Now, one of these things, so certainly, like, okay, they use the example of finches on the
Galapagos Islands,
right?
Yes.
So
much good evolution.
Yeah. So when they sort of begin to speciate, one gets a larger beak, one gets smaller beak. They fill certain niches. They feed on certain things. When a resource niche is filled, competition kicks in, and so no new finches emerge, and extinctions take over if you were one of the ones caught in between, because you now get outcompeted, I suppose, for those niches. With the humans, the more of us there were, the more sort of speciations seemed to take place, and that we coexisted with our old forms. So there's this whole budding aspect of this.
There's the budding, but not necessarily the replacement. And so there would be the coexistence for a very long period of time with enough differences that, it probably had to do with places that hominins went, right? And the things that they ate or that they survived on, and like, who you hang out with on this, I like this crew over here, I'm like,
So certainly tool use would be a major factor, because this is something that allows humans uniquely to adapt to a new climate, a new resource, a new habitat, a new method of feeding ourselves, use of fire, of course, so that we can survive in different climates if we need the heat, or to cook something so we don't, to make a thing edible. So we can have this sort of budding speciation where we may be physically adapting to a new environment, but we don't need to completely diverge from the plan of hominin, because we have all these tools that can give us sharp things to poke with, or allow us to go after. Or
that's part of the evolution, right? Oh, look at me! I've got these new ideas and these. Yeah, look at me! I'm going with it.
Part of our evolution, but it also, in a way, stunts it, right? Because why aren't there people with claws? Okay, well, we invented sharp things. So if we are needing to cut,
right, because of tool use, and so I think this gets at like the next step, right? Where people have like come up with the next step in human evolution, which is like, Homo futura or Homo techno, or, like there are like many different names that people have come up with to define the next stage in human adaptation and evolution. And so there is a big question, right? Where if technology and information are the dividing line, is that what's going to be the next step? Is it going to be those that adapt to the modern technological environment are the ones that are able to continue, and those that are not, continue, but in a different way? Is that what makes the difference? Is it going to be the Homo cyborg, right? Where people start actually, putting more technology into their selves, into their bodies. How is technology actually going to impact if this coevolution and speciation continues, if we take it to the next extreme? I think that's the next interesting
Right.
question.
And so what I think I'm getting at here is also or getting from this study is that technology stunts the need for physical evolution.
Yes.
To the extent that when we get the cyborg human of the future who has adapted to the integration of technology with mental brain and chip things and robotic elbows, that's what I think. This is what I think the cyborgs will have. They're just going to have robotic elbows. This is how I picture the future.
Robots with
they
elbows.
They would still be able, because they don't need to physically adapt rapidly or even over time to this new scenario, because it's been augmented by technology. They would still be able to interbreed with, say, a Neanderthal, or perhaps even Homo erectus. This is also what has accelerated some of this speciation, is that even when we have diverged from our earlier hominin ancestors, we surprisingly discovered we were still able to reproduce, like with what we've seen with the Neanderthals. Neanderthals were also able to reproduce with something very likely Homo erectus. We have this idea, usually in evolution, that these begin when these separations take place. Horse and donkey can breed with each other, but then their offspring can't. So there's usually things that are shutting this down,
get in the way,
with the genetic drifts and what have you.
Mm-hmm.
But because hominins have done this technology adaptation, our physical adaptations haven't needed to really adjust to anything. So even
I think that's going to be an interesting question moving. Yeah. How's that going to impact it moving forward? Yeah. It's still technology, right? You're not having to adapt much in the other reproductive aspects.
And honestly,
but with IVF and other things, we've talked about that, but how is it going to impact stuff?
We've looked at if you look at our technology, what is it designed around? It's designed around the existing physical form of humans.
But that's changing also because of more accessibility stuff. And now we've got prosthetic advancements, and we've got, basically mecha suits that are being developed for people who are paralyzed. These things are going to change not just people who have lost use or have limited use of their physical bodies, or, due to genetic or lifetime traumas, but at the same time, like, technology is going to allow individuals to live and reproduce and continue having lives, beyond the point that historically they would have been able to. We've been watching that expand more and more. Yeah.
But in driving evolution, the fact that we've designed our keyboard to work with the digits that we already have, we may end up with longer thumbs. I think
better thumbs that don't lead to carpal tunnel. Like, maybe less carpal tunnel as we adapt. I don't know.
But we designed technology around the existing form, so that also, I think, is what would prevent a need for a large physical adaptation to our world, because we built it
Mhm.
around the aesthetic uh, of the current modern human.
We'll see how that changes, though, as we move into space and beyond. Hey, everyone, this is This Week in Science. I'm Dr. Kiki. Yes. And we're so glad that you're joining us for our show. And we love that you're here. And we hope that you invite other people to join us. Tell them about This Week in Science. Share TWIS with others. Get them to subscribe to the podcast. Get them to come and watch a live show Wednesday, 8 p.m. Pacific time, Facebook, Twitch, or YouTube, and then get them to subscribe to those channels and get notifications turned on. I mean, more people enjoying the show means more to enjoy all the way around for everyone. So let's come back for a little bit more science conversation with TWIS. I just
Did
made
we
up
used
that
to have
new-
bumper music in the middle of the show?
We did. I got rid of it. Now I'm
Okay.
just making up little songs.
That was great.
Which,
I like it.
thanks. Yeah, totally good. Not bad at all. It's totally fine. All right. So I know the people on Twitch especially, but many of our viewers, our listeners, are gamers. Do you play video games, Justin?
I have been known to
known to
play game to
dabble?
the point where
You got sore thumbs and carpal
I'll
tunnel?
do a little shout out to a show that is currently on Amazon Prime. There's a series called Fallout that in
Yeah,
my
just
youth
released. Mhm.
it was a video game that I played a lot of, and I've even gone into line of work now where I'm basically a vault dweller. It's basically you go into this vault and you work there for long hours, and then you come back out and you're like, oh, the real world is not as organized and it's more chaotic than the vault world. But Fallout was a game. It was probably the game I had played the most and liked the most out of all the video games that have existed.
There are so many great ones. So
And
many.
they made a game.
amazing-
They made a show out of
whole
it.
show
now.
out of it. Yeah.
It's fantastic.
I think there are a few that have become shows, which is pretty cool. I love it. But in those games, nobody's really played with adding a mini game that could be used for science. So we reported back almost 20 years ago now on Fold It. When Fold It first emerged, it gamified. It started to turn science and solving puzzles of the form of DNA and proteins. It turned it into a game, right? It turned it into a puzzle-solving game. And so that was a separate thing. Great success, but it was limited in the number of people that found it, downloaded it, or put it on their computers and accessed it. And through the years, there have been improvements in the way that scientists have developed these kind of gamified citizen science efforts. And the Galaxy Zoo is a really, really good example of one that worked really well, where we'd go but it's its own thing, right? You'd have to go to Galaxy Zoo to match galaxies and types of galaxies for that wonderful pattern recognition and puzzle solving aspect. These researchers who have just published their study in Nature Biotechnology have advanced science by using the power of 4.5 million gamers around the world. They integrated a mini game, into Borderlands 3. Borderlands 3 is a really popular multiplayer, the role-playing game. Again, it's, a lot of stuff going on in the game itself, but you get to a certain point in the game And the researchers worked with the developers of Borderlands and got them to integrate this mini game into one of the levels of Borderlands. So like people who get to a level, they have a choice. They could do this little mini game. And in the mini game, what they were asked to do is basically solve a puzzle. And the puzzle was to stack blocks in a particular way. It's like, oh, these blocks aren't stacked appropriately, so you have to move them. It's kind of like Tetris a little bit, but a little more complicated. And so they put out over 1 million mini games, different games within the big game that they expected. Their goal was to have them played with a mean number of about 45 times each. So a number of different people, individuals trying these games. The games had a guide that you were going to try and match, and then you had to fill in these gaps or remove gaps to achieve the proper formation. And the researchers used how people solved the puzzle to improve their ability to put a whole bunch of little DNA fragments together to be able to do a better assessment of gut microbes. So specifically, they were looking at a gut microbe that is very common around the world, and I think it was scrolling down, and anyway, they're looking to see how these microbial communities change in response to lifestyle habits, so related to toothbrushing and the diet, or whether you drink alcohol and all these different things. And so they've seen different proportions of mutations and adaptations within the microbial communities, within these little tiny segments of DNA that they have to piece together to create whole genomes for the bacteria. And so they're using the gaming power of these millions of people around the world playing Borderlands, which is now this Borderlands science. They were able to help improve that piecing together and the structuring of the microbial genomes from gameplay.
Super cool.
Yeah. So people were like, yeah, I'll play it. And the way that they set up their game, I guess in other game setups historically that have worked well, you have like a few super users that are like the top 1% of people who play the game all the time. And they're the ones who do the majority of the data analysis or the matching and the puzzle solving. And so the majority of people aren't really involved. But the way they set up the game for this Borderlands science, there are super users, but at the same time, the majority of people, their data is still important. So even if you play 1 to 2 games and you don't play that many, you're still going to be a big influence in the data sets overall, just in the way they set up their analysis. But anyway, I think the exciting thing here is, not just the methodology for cleaning up their using people-powered pattern recognition to clean up their data sets and to do their matching for them better, which it did. They've used AI in the past to do this, and people actually improved over AI's performance by a significant amount in this study. And that's why, again.
And then they had AI analyze how the humans did it. Now AI is better.
Yeah, probably right.
Wait, how long did that take?
20
minutes.
20 minutes, just a little bit of time. Anyway, I think it's very exciting. I love that it's pushing the envelope of how science is integrated into video games, and super exciting.
And so we could also go the other direction with this.
Don't go away and go to the science. The science will come to you, right? Let's go to where the people are, which is what they just did.
So one of the great things about video games versus all other forms of media is that it is interactive. It requires participation to play the game. You are part of, you have to think your way through a game versus you can be watching a movie or even reading a book and your mind can drift off and just allow a thing to be told to you, a thing to be played at you.
Mm-hmm.
We've talked about this before. Our education system is still behind video games in terms of structuring learning. You know, a video game has that structure. You start out, it's almost like a tutorial. Here's some easy things, some obvious things. Here's how you play the game. And you go through and you go, I do this, I get that, I go this, I go do this thing.
This and that. And this
You
and
learn level 1. Oh, then level 2, things are trickier. But you can use the things that you learned in level 1 to figure out how to do level 2. And then they're progressively teaching you how to solve the puzzles of the game or how to do this sort of thing. This is a study that's not in our rundown, but
What?
this was a project that took place at the University of Warwick.
This is the study where it's the games are better for learning of the math and stuff? Yes. Okay. Tell me.
Did you bring this one also?
No, but I looked at it, and so I find it fascinating that you also, in the back of your head, were like, "Oh, this is like a close second." But like,
this is one I had up there. It's just it had too much math involved for me to figure out what was really going on. So
what's
it's like,
happening?
If the article was a game, I would totally be able to tell you what happened. But they replaced the mathematical structured lectures that they normally present to students for statistics, and found that they could increase. They doubled the amount of, they reduced by about a third the amount of people who failed the statistics class. That makes sense. They replaced the normal lecture with game based learning for the students. And they found, at the end of the course, the students who had played the games versus the typical way of getting the information were better at it. They found that there was an increase, even in the ones who were good at statistics already, who were, comparatively in groups who got good grades. The overall scores were higher across. Plus, there were less people that failed because it pushed all scores up in terms of at least being able to pass the course and understand the content. And so I didn't want to make a whole big deal about this story because I don't have it all out in front of me. But like one of the things I think is just amazing at this point in how well people have taken on gaming and how it's taken over from a lot of media to that now that like old media is like, hey, we can make a movie out of that. Yeah. It used to be the other way around.
Exactly.
You're like, oh, we can make a horribly themed video game based on a movie that was popular.
It's marketing
now they're having
also.
to go the other way.
Cross marketing, you know how it works.
But now they have to also have like, you can't just make like I was talking about Fallout.
Right.
It's like, oh, they better have done a good job because there's a fan base that's going to be
so
you
mad
don't
if they didn't.
understand
You
the
didn't
world
get it right.
that you're in. But they did. They did a great job. They did fantastic. I'm very happy with the results.
I haven't watched it yet. I have yet to dive into the Fallout, but I'm sure it'll come
But
soon.
there needs to be, I think, more gaming in education system.
I agree. Yeah.
There's still some thought that the gaming is a frivolous activity, and it certainly is for the most part.
But the games that they do add are still like they're very highly educational. And like I watch my son struggle through his, 7th grade math class, and he's having so many issues, and like he gets mad at the videos and the online little games that he's just like, he feels insulted by it basically. He's like, this is wasting my time, and he gets frustrated. yet, so he is learning, basic statistics, probability in his 7th grade class, box plots, mean, average, the uh, the deviation from the mean, all these kinds of ideas that come along with statistics. They're trying to teach right now these basic ideas in his math class. And then he shows me, he's teaching himself how to make a video game in Unreal Engine. He downloaded the Epic game engine, Unreal, and he is making a video game based on a game that he likes a lot. And he's like, oh, I'm going to do this thing. And he created his own yesterday. He's like, Mommy, here's my homework. What's a sample space? And I'm like, oh, well, that's the space of things that you're going to be sampling, right? So it's like you're spinning a dial, how many times do you spin the dial and what are the results? That's your sample space, But he created this thing in the game where he's like, okay, so I want people to be able to create their own galaxies. And so they can put an image into my universe that I'm making, any image. And then this program, and he's created this wire thing of like all these commands that make this thing happen, that it's going to randomly generate based on the pixel that the scanner is going through in the image that somebody uploads, whether there's light or no light. So it's like a black or a white, like yes or no. It just changes the image to gray, to black or white grayscale, and decides whether there's light or no light. And then there's a 1 out of 3 times it's going to just like make a star or not make a star. So it's not going to be just stars everywhere. People aren't going to make stars, but they'll be able to make galaxies that are like shapes of images that they upload, but it's not completely right, but it kind of refers back to it. And like in his modeling, he's putting randomization and sampling and doing basic statistics, and he understands this already better than his teacher probably does. But the class and the way they test it is not going to understand this. So, yeah. So I'm like, Kai, if you can just turn every statistics or math problem into something related to your video game stuff, you're gonna blow everyone out of the water. You got it. You've got it. Because he was explaining it to me, and he knew what was going on. He understood randomization. He understood sampling. He's understood the probabilities and like how that would fall out. And I was just, yeah, boggles my mind.
So,
Education.
yeah.
Who's educating whom?
And so part of the thing is when you use specific examples, you sometimes limit an education. So sometimes using hard math that has randomized things that aren't applied to a specific situation can become more universal in your thinking.
Right. And universal thinking, being able to like cross over different, like for Kai to be able to take the video game statistics and randomization and apply it to dice, or, these schools, like if that crossover can take place, that's where real understanding and like that real integration of knowledge takes place.
Yeah. But if you're being presented with the information, in a class, an old type of classroom setting, it can get, they have a lot of difficulty, I think, in my memory of math, in bridging the gap between an abstract and a physical world in a way that a virtual realm like a video game doesn't really have that problem, because it creates the whatever thing that you're applying it to in front of you, and you can change that endlessly. One of the
seriously, you create a real world situation where suddenly you have to add and subtract like money to be able to buy goods in a virtual world, or then you have to have to figure out probabilities, like what's my chance of winning, if I have these powers and this is what I have, and this is the potential outcome, do I want to fight or do I want to flee, what decision do you make? Suddenly you incorporate all this knowledge, which is everyday stuff, It's part of the decisions that we all make every day,
It is.
but it
A-
makes it makes them more real.
And I think what's missing from the video game world is converting it back into the abstract. They've got you participating. They have all of this analysis sort of becoming common sense as you do puzzles or run tasks or based on your odds, choose a path, right? But it needs to then, for it to be an education system, it has to convert it back into that abstract math that you can go, I can apply this in other places. What the education system has failed to do is, like, if any of my kids came home with a question that had to do with trains, I told them,
forget about the trains.
There's no trains.
There's
anymore.
no trains.
People like kids aren't fascinated by the big locomotive anymore. This is almost 100-year-old.
Let's talk about Lyfts and Ubers. Let's talk about
if you're going to try to put it into that relatable field of your virtual universe, all the education system needs to update it and understand what the kids are going to be applying it to. Because if you're using trains, they're like,
who does what? What train? What train leaves where and what goes where? No, but if you talk about you have to catch a plane in Chicago, but you're going to have a layover.
I'm 12 years old. What are you talking about, a plane in Chicago?
What are you talking about?
Right. So the applied side is where it's really they can offer you all the abstract, but they can't really give it a whole lot of relevance in the other way. So there needs to be a combination. Anyway, it sounds like they found some sort of an in-between here of a game that was based on this statistical model that could connect to the abstract. And they found stunning results. So more of it, please.
Absolutely. And as a sideline, Schnago presented us with a Neanderthal cyborg with robot elbows over in the Discord. So if you're supporting us on Patreon, you can join that Discord at whatever level of support over on Patreon. Just get in touch with me on Patreon if you need that link. But yeah, what Neanderthal cyborg with robot elbows? Only possible with AI these days. Oh my goodness. Moving on from games, let's get into the world of accidentally sending space boulders to hit Mars in several thousand years.
Oh, did we now?
Yeah, so the DART mission, which was very successful, we ran our spacecraft into an asteroid, Didymus, and Dimorphos, or actually the Dimorphos, where it was slammed into. Anyway, Didymus and Dimorphos. There's two asteroid system. One of them was a little moon, and we slammed the DART spacecraft into the moon, and it was like, oh, we nudged it, and we saw this big plume of dust and rubble, and we were like, look at that. That's cool. And in the back of my mind, I was like, I wonder where that little cloud of dust and rubble is going to end up. And I kind of thought, oh, it's just going to like swirl back into that little asteroid system. It's not hit so hard it's going to escape and do an escape trajectory and head up going somewhere. Anyway, apparently there are some little boulders that have been shot away from the Dimorphos Didymus system. Hi, Kai, I love you.
Hello, I need to tell you something.
No, I'm on the air.
Important.
Really important?
Yeah, stay away from the sink.
Stay away from the sink.
Yeah.
I will stay away from the sink.
Yeah, I'll explain it more later, but just don't touch anything near the sink.
Don't touch anything.
Or the fridge.
Or the fridge. Dear Lord. Okay, this is what I get.
Actually, it's dangerous.
I will not touch the sink or the fridge. Hello, Cappy. Thanks, Kai. Oh my goodness. These are the messages that we get. I don't know what's happening upstairs. I don't know what's going on. I'm not in charge. Apparently it's dangerous. This is what happens when I leave to do TWIS. The upstairs and the sink and the fridge become dangers. Okay. Let's see. Moving on in this story of Dimorphos Didymus space boulders. Researchers decided that it would be a great idea for them to analyze the debris ejecta and to see, okay, where's it going? Is it anything that we need to be concerned about? And, of course, the question is mostly, is it something that we need to worry about for Earth? Is that something that we need to be concerned about? And so that was, probably where the analysis really came from. But, it's also curious, like, where is that plume of ejecta going to end up? What's happening? What's in there in that plume of ejecta that apparently had some big boulder-sized chunks in it? Where did that go? And the researchers just published their work and were able to do some time analysis evolution between Earth and Mars and look at like these 3,700 boulders that were generated. It's not just little rubble ejecta, boulders. And we're able to determine this, the orbit of Didymus and what was happening with those boulders and how they were moving around the different, the asteroids and where they would eventually end up leaving and going. And so they kept looking at things and the velocity and how many of them there were. And eventually they came to determine that in about 6,000 to 10,000, 15,000 years or so, many of those boulders will make their way not to Earth, but to Mars. And when they get to Mars, Mars doesn't have an atmosphere like Earth does. And so Earth, given the same size boulder, it would be like, and it would be a thing, but it wouldn't be a big thing. It would rubbleify in our atmosphere. Mars doesn't have that. And so these boulders are pretty much, if they are solid enough to not, like, if they're soft, then fine. Maybe they'll rubbleify and it'll just be like a
soft boulder. Come on.
Rubble field on the surface of Mars. But yeah, in some several thousand years, we tossed boulders at Mars with our DART mission. And they are going to hit the surface of Mars, most likely. We don't know. Come very close to Mars. Probably hit the surface of Mars. Could create 300-meter large impact craters. If they do not.
That's a lot.
It's not little. 300 meters.
3 football fields.
Yes, this is big. Yes. And we did that. Congratulations, humans. You did great.
Now,
oops.
The upside is there's nothing on Mars to disrupt. Now,
but in 6,000 years?
1,000 years from now?
Yes.
If there's a humanity?
Yeah, and we have Martians that we have sent there. Oops. Oh, I forgot about that. We stopped looking at those. That was so many system updates.
We had to leave the Earth because of one certain time period of human decided to burn all the fossil fuels. So we moved to Mars. Fine. And then it turns out, while they were burning all the fossil fuels and heating up our planet, they also decided, hey, let's just mess around with blowing up some asteroids. And then they laughed about it.
We will be brought up in the historical documents.
We're the worst.
Laughing.
Admit it. It's us. We're the worst humans of all human time. And it was all us.
Oh, pitiful humans.
Pre-bombing our own Mars settlements.
Exactly.
Thank you for pointing it out, yes.
We did. We did. It's just fantastic and ridiculous to me, but it just is. Oh, my goodness. What have we done? DART, very successful.
To be fair, we did not.
Who knew?
To be fair, we did not know ahead of time.
We didn't know anything, but we went ahead and did it. This
We
is
did
so
it anyway.
typical.
Yeah. It's just-
I'll just
Well,
see what happens. I mean, what if one of those had been a bigger boulder and it actually wasn't a trajectory that would impact Earth? Like we'd be
well, I think we knew.
Oh.
I hope we knew it wasn't going to make it to Earth, but
thought it was
we
far
have the
enough
atmosphere.
away.
Although
Wait,
when you're talking about big boulders, most of the shooting stars you see, right? They're like this pebble or smaller dust even hitting the atmosphere is enough to make those streaks that we see. Tiny little grains of sand and pebbly things. Something like like a boulder. Oh my goodness. That might actually make it in.
It might make it in. Tunguska, here we come. Let's do it again. You want to tell me another story from a long time ago?
Last story I got here is this is the archaeological excavations in Germany back in the 90s that found all sorts of wooden poles. And they were like, oh, those are just, there was controversy at the time that these were initially looked like early human spears, but the dates were all wrong for modern humans to have made them. They came in at around 200, and then once they were like, oh, that can't be right, they looked harder, and it's, maybe 300,000 years ago.
Wow.
They could only have been made by Neanderthals. Not current modern humans. And they said, oh, well, then these must just be sticks. And then they said, well, yeah, they're long and they're sharpened, and they built replicas of them, and they found that they were really good weighted distribution for throwing.
They were really good sticks.
Yeah, they were, in fact, spears, probably designed for hunting. And they have also uncovered now and analyzed many, many more wooden artifacts from the same site. This is they use state-of-the-art imaging techniques, 3D microscopy, micro CT scanners, and they produced some surprising results. Researchers were able to determine how the wood was worked. This is first author Dr. Dirk Letter, who is from the Lower Saxony State Office for Cultural Heritage. There's evidence of much more extensive and varied processing of spruce and pine wood than previously thought. Selected logs were shaped into spears and throwing sticks and brought to the site, while broken tools were repaired and recycled into other things on site. At least 20 spears and throwing sticks had been left behind at what was in the past would have been a lake shore. This extraordinary state of the preservation of the wood had enabled researchers for the first time to document and identify these woodworking techniques in detail. So what's really amazing about this is that we've talked about this quite a bit before, is all of the missing artifacts that are made of wood. We don't see a lot of it. And so it's almost as though woodworking couldn't have come along until metalworking, until after metalworking allowed us to shape and craft things more precisely.
Yeah.
But we're finding more and more evidence that woodworking, there's also I think it's a site in Morocco or Libya. No, not Morocco. It can't be Morocco. It's somewhere, it might be Libya. Somewhere in northern Africa anyway, where they found a submerged structure, which it looks like it was a carved section of a large timber that was placed over another one, as though it was part of some larger wooden structure that had been created. And that thing dated to about 400,000 years. So what we're seeing is that, of course, people were doing woodworking.
Before
people were making wooden tools.
Before we have our Stone Age, Iron Age.
Well, not before our Stone Age. Our Stone Age
led to the woodworking?
Our Stone Age is a couple million years old for sure.
Yeah, wood would have been, but wood, we're not going to see the remnants of it. So we're probably going to see the more recent. Yeah.
Yeah, this is some of the oldest woodworked, wood crafting evidence that we have ever seen at 300,000 years old. All these tools and spears. And so because they're invisible, because wood deteriorates and stone doesn't, we see all the stone tools that go back millions of years. Axes that we know were for cutting and clefting out meat. But what if all this time these stone tools were actually being used to make woodworking tools, right? Like we wouldn't know because all the
Yeah.
wood deteriorates. It's very,
Yeah.
very hard to find the old preserved wood. These happen to be buried next to a lake bed. What was a lake bed? They were covered in the soil and managed to be preserved. This is a lucky find in the first place.
Seriously.
Yeah, a lot of
for the situation to even allow for these finds. Like this is amazing.
And so it does bring up the possibility that woodworking, that a lot of stone tool manufacturing was made to then do woodworking with. And that wasn't just used this little hand axe to cleft an animal. They had spears, which without this find, we don't know Neanderthals had these big, long throwing spears and hunted this way. Because this also means that they weren't necessarily what we always considered them to be as direct hunters, where they have to come in contact directly with the animal, and which they may have done quite a bit, but they could throw a spear and hit a thing. Now, this might have been for fish, for spearing
Could have been
fish.
for whatever it was, but this is like a new idea also of Neanderthals, right? Okay, they had stone stuff. They did some things. Oh, medicine, maybe. Oh, did social groups. Okay, yeah, maybe they're. Oh, wow. Now, oh, wow, spears. Okay, so we're going to add to that. We thought that just people, humans.
Yeah, and so and this is also something that we've brought up a bunch of times too about the distribution of hominins not making sense in certain places because islands, because of water, because of ocean, because of how long it would take to swim or even float somewhere. It's so difficult. If we have this kind of fine woodworking ability as a Neanderthal 300,000 years ago, then it opens up possibilities for early humans to have been pretty good at woodworking all along, and boat making much more likely. Not maybe, great boats, but better than we think.
Exactly. And it's a matter of finding them, right? How many of them made it across whatever body of water, and then where did they land? And
because there's even before Neanderthal, there's a Homo erectus in the islands of in Oceania that
for certain
don't make sense for any point in climactic change. It doesn't mean that it got shallow enough it was never walkable. There was places where there were humans that were in the ancient world that predate Neanderthal that could not have walked there.
And now you're like,
not have
there's something going on there.
Yeah,
Maybe
they could not have made it physically by swimming or by walking.
And we know that wooden tools didn't just appear out of nowhere, right? So
with woodworking techniques 300,000 years ago, they didn't just get invented. And we know Neanderthals passed on knowledge. We know the Homo erectus preserved knowledge of stone tool making that was consistent over millions of years. So if they were applying that consistent use of those stone tools to woodworking, that means that woodworking would have also been persisting throughout that time. We don't have evidence of it, but again, we have to make a big allowance for the possibility of woodworking tools going much further back, because we know of how hard the evidence of that would be to find.
And this being great evidence.
When we do find an example of it, it has to then push back the existence quite a while. For instance, like we know that when we see any fossil of bone, we can't say, aha, this is the oldest fossil that we have of any species. We don't say, this is when it started. we know we just happen to find a fossil.
Yes.
And so
then you have to figure it
the
out.
thing we found a fossil of probably existed for quite a long time before that. Statistically,
Moment in
we
time.
very
That's all we
likely
have. Snapshots.
is to find the first one. Right? We found one in the mix somewhere. We'll guess it's in the middle. It probably exists quite a long time before the first example. So when we find the earliest,
Vincent Fink in YouTube is saying, what about beavers? They were doing it for millions of years, right? We probably copied what we saw them doing. Like
humans learn from nature all the
right?
time.
Everything around them. Oh, that's a great idea. Copy, adapt, paste.
You have the stone tools that you can use to craft things with for a few million years. You just didn't think of it, of crafting on the softer thing.
Nobody ever
with
thought you have the hard thing with the
hard
soft thing.
sharp thing you've already got, but you didn't use the other. Of course you did.
Yes.
No fool.
Nope. Yeah. I mean, we can't jump to assumptions without the evidence, but I think this is part of the evidence that builds a very, very convincing story that these kinds of tools and abilities were around much, much earlier than we have ever given them credit for. So
yeah, I think so too.
And what?
The thing I'm most curious about that I can't get out of my head.
Okay.
What did Kai do to the sink in the refrigerator that you're not allowed to even touch it?
I don't know. I haven't gotten upstairs yet. I have no idea.
I mean, he didn't say, like, don't look in the kitchen.
No, it was
very specifically, don't touch anything in the kitchen.
And he said, it's dangerous.
And then he walked away and you were like, okay, I don't have any plans. But where did
There's some cycling going on in the, I don't know.
What is happening at your house right now that you're not aware of but need to avoid? Like,
probably everything. I'm gonna sneak upstairs after the show and just
avoid the kitchen. So you can go and investigate.
Avoid the kitchen entirely. Go straight to bed. Do not pass go.
Is this what it's come down to? It's just like
I'm not in charge.
I don't want to know.
I don't want to know.
I don't want to know until I've had my sleep. I'll wait until tomorrow to find out.
Kai or Marshall decided that now was the time to fix something. And
can you just buy them some caution tape? And then they can just...
I do need to just buy a roll of like, do not cross caution, yellow tape. Like, yes, I need to do this. And then they can tell me where I need to not be. Just put up the tape. Don't go there, Mom. Nope, don't go there. Okay, better be clean.
I think we should
better
either
be
end
by
the
the
show
time
so
it's done.
that you can go and investigate, or so you can get enough sleep to handle the aftermath of what has been done to your house.
Absolutely. But I do have two quick stories to finish up this show with. Number one, we hear the story all the time that bonobos, there are peaceful relatives, right? So much more peaceful than chimpanzees. Make love, not be aggressive, don't do battle. It's the female-run society, so everything's better, right? Well, these researchers were like, okay, we hear this story all the time, but let's really go in and look at what the males are doing in bonobos versus chimpanzees. And so they looked at 14 years worth of data from two different sites, one for bonobos, the Kokolapori bonobos, and then compared that to chimpanzees in Gombe. And what they found, which is really fascinating, is that, bonobos, the ladies are in charge. So the women are kind of the ones who are in deciding when they're going to mate, who's going to mate, and what's going on. And so the males are always going to be not aggressive to the females because they want to have their chance. But that doesn't mean there's no infighting between the males, themselves. And so in this study, they showed that compared to chimpanzees, when it comes down to total aggressive acts, bonobo males are actually more aggressive to other males than the chimpanzee compatriots. So bonobo males, when it all comes down to like the contact aggression, the little bumps, the nudges, the get out of here kind of things, big fights too. But overall, bonobo males are more aggressive than chimpanzees. And the thing about it is basically it's because of the difference in the society, where chimpanzees, it's a male-dominated hierarchy, and so the chimpanzees, the young males have to
Gotta get in
cooperate
line.
and
Gotta
get in
Know
line.
your role.
Know your role. But if you're going to build your ability, you have to have friends. And so you don't go against the other males because you actually might end up taking down females. And so there's actually more male to female aggression in chimpanzees than there is in bonobos. And in bonobos, there's more female to male aggression than there is in chimpanzees.
So much domestic violence in that.
Right. And then when it comes down to it, the bonobo males, they are waiting their turn to be like, they're put in their place by the females, but then amongst themselves, they're like, no, competition. You're my competition. You're my, and they don't collaborate with, they're not nice to each other. They fight more.
Yeah. None of us are in charge. Only one of us is leaving with the prize.
Yeah. 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 Even there might be more prize because of, oh, let's all be nice to each other. No, it's really the females who are like, no, females are going to be nice to each other. Males, go away. Everybody, let's calm down. Males, go away. But yeah, so the whole idea of bonobos being more peaceful overall than chimpanzees, not necessarily true. And it kind of bears out in the data when you think about why the males and females would be aggressive in different ways based on their social structure. So anyway, that's one.
To flip it back to chimpanzees.
Yeah.
One of the only known serial killers in the chimpanzee world, or famously known, is a female chimpanzee who is killing the offspring of other female chimpanzees. So maybe that dynamic also continues in the chimpanzee world with a lot more female to female aggression and violence taking place because they're not in charge and they're in competition as well.
Right.
It might be a thing that works with humans as well.
More violence. No, less violence.
If nobody's in charge, if nobody has the power of state, maybe there's more violence.
This is a very interesting question. So let's talk about the last story, which is bacterial vampires.
Dun,
They
dun,
like
dun.
to suck your blood. Yes. So Washington State University researchers were like, oh, look at these species of bacteria that colonize our guts. And some people have irritable bowel disease. And sometimes when combination of irritable bowel disease and the bacteria combine, you suddenly have a situation where there's inflammation, and in certain individuals, about 10%, maybe 20% of those who are actually have these bacterial pathogens, they get bleeds in their guts. And there are certain species of those bacteria that are like, I like the blood. And then they invade the bloodstream through these little bleeds in the GI system. And about 2% of people usually will end up dying because of sepsis, bacterial infections of the blood that they gained because of infections that started in the gut, because of bowel disease issues, complications. So these researchers were like, what is it that leads these particular bacteria into the bloodstream to like cause sepsis in the first place? And they found it's that the bacteria really, really like a particular amino acid that is present in human blood. And they're like, I want to just go get that. And so Salmonella enterica Escherichia coli, Citrobacter courseri. These bacteria have a chemoreceptor that's TSR, a TSR chemoreceptor that leads chemotaxis. So even with femto-level concentrations, so like to the negative 15th of like concentrations, so 0.0000000, all the negative 15th of concentrations of human blood serum in an experimental setup, they found these bacteria were like, whoop, we like that, whatever it is, and we're going to go after it. And so this TSR chemoreceptor was a thing that figured it out. And the TSR has a conserved amino acid recognition motif within it for L-serine. L-serine is an amino acid. It's the one that cats are obligate carnivores for and have to eat from their meat diet to get. And so these bacteria also really, really love L-serine and want to go get it. And they
So
are
it's not even the
designed
hammer. They're not
to
even
get
after
it.
the iron. They're not even after the red stuff. It's
Amino
just
acid.
the
L-serine.
serum, the fluid in which the blood is moving
Yes.
that they're after.
The stuff that's in
Okay.
it. Yeah. And so what they have found is that just even this human serum, these bacteria just they want it, they need it, they have a chemoreceptor for it, and so they're going to go after it, and that's going to drive them into lesions in the gut and lead to those septic infections that can end up being serious enough to end life. So these blood-loving bacteria, it's not just human blood, but this is this factor, L-serine, is common in muscle tissue, blood in a lot of mammals, meat, and the
Yeah.
bacteria want to get it too.
So it's I'm guessing they're eating the nutrients that your blood and muscles need
Mhm.
that they're bathed in, right?
Yes.
So they're going in like, oh, well, we like this too. We're tissue. We're gonna go ahead and gobble
get
up
it.
all the nutrients that you would normally use to feed your blood and basically starve you out in some way.
Yeah.
Stay
And
out.
so you don't want the bacteria in your bloodstream, but knowing why the bacteria are headed into your bloodstream in the first place is a really great place for scientists to start developing treatments and ways to push them way out.
Antibiotic blood?
Maybe.
I don't know.
Who knows? How can we do it? We'll figure it out. But yeah, there are this new phrase, which I think is fantastic. These researchers in their paper, and we have coined a new phrase, this colonization of hemorrhagic lesions and the consumption of serum nutrients as bacterial vampirism. So good for you, scientists.
Yeah.
You've defined bacterial vampires. Now you have to stake them in the heart, just move them out, way out. Look at me, cheerleader for science.
So
But that was
I
my
guess
last
the
story.
moral of the story is don't bleed.
Don't
Don't
ever
bleed. If you're bleeding
bleed.
out, you could be inviting in.
Don't bleed in your gut. Don't let the bacteria in.
But can't they get in anywhere? Is it just gut? I mean, wouldn't they?
Well, they
Don't have
could
any
get in
cuts.
anywhere, but so this is probably something that leads to infections, septic infections that come from lesions in the mouth. But very often these are gut colonizing bacteria. So they're just there to begin with, and then you add in
And I
a
guess
lesion and blood and
aerobic, anaerobic situation too. So that could be
Yes.
different from outside bacteria. Okay.
yeah, exactly. You got it. Thank you for coming to that logic in front of everyone. We have done the show. I need to find out what's happening with my sink and kitchen. Yeah? Yeah.
If
Are we ready to...
you dare.
Do I dare? No, I'm going to sneak upstairs. Although I didn't eat dinner and I have to go eat dinner and it's upstairs in the kitchen. Wanted
It
them to see.
was. Maybe
was.
that's the dangerous thing. Maybe they've done something to the food. The fact that you've managed to sit through the rest of this episode without finding out what the heck just happened.
I will
Like,
find
you got
out.
an
I
in-person
know
warning.
I'll find out. What am I going to change? I'm just going to go in. I can't go in there and be like, I'm going to fix everything.
But
No,
I just love
they
that.
did something.
So, Mom,
Mommy.
don't want you to touch anything in the sink. Oh, and the refrigerator. And actually, the floor between the sink and the refrigerator also probably should be off limits.
Dangerous.
For how long, I'm not saying.
Very dangerous.
How
kitchen.
dangerous? Just avoid it completely. No interactions. No touching.
No touching.
Do you have safety goggles? I think you should. You need to wear them.
I wish I
before
had
you
cool
go
safety goggles like
near
yours,
the kitchen.
Justin. Seriously. Yours are so fancy. Are those
These are
prescription safety
Vault-Tec
goggles?
issued.
Oh, that's amazing.
Vault-Tec issued safety goggles. Always be prepared.
Be prepared for things flying at your eyes, for the splatter, for all those moments in life, for Kiki's kitchen. If only I had Vault-Tec goggles. Thank you, everyone, for listening to the show tonight. We really do hope that you enjoyed what we had to offer in terms of science and discussion. Big shout outs to Fada for all the help with social media and show notes, especially over the last couple of weeks as things have been in and out with the conference that I was putting together last week. And with the social eclipse? No, solar eclipse. That's what happened. Everybody had a lot going on last week. Identity 4, thank you so much for recording the show. Gord, Arnlor, others, thank you for making sure that the chat rooms on all the channels are really great places to hang out. And Rachel, I really want to say thank you for being a part of editing this show and staying on top of that, even when I'm not on top of things myself. So really appreciate all your work. And I have to say thank you, of course, to our TWIS patrons. So the people who really help make this show happen are those who support us on Patreon. Thank you to Alan Viola, Aaron Anathema, Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Kent Northcote, George Corris, P.L. Verizarb, I just mumbled that, John Ratnaswamy, Chris Wozniak, Vigard Shefstad, Donathan Styles, a.k.a. Don Stylo, Ali Coffin, Reagan Shubrew, Sarah Forfar, Don Mundus, P.I.G., Stephen Alberon, Daryl Myshak, Andrew Swanson, Fredus 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hesflo, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard Brendan Minish, Johnny Gridley, Remy Dave, G. Burton Lattimore, Flying Out, Christopher Dreyer, RDM, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Rick Ramus, Philip Shane, Cartlerson, I'm the mumble, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, Lon Makes, EO, Adam Mishkan, Kevin Parachan, Aaron Luthen, Bob Calder, Marjorie, Paul D. Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you all for your support on Patreon. And if you would like to support us, if you're not already, head over to twist.org and click on that Patreon link. Choose your level of support. And I hope that I'll be reading your name in the future. We will be back.
Yeah, Wednesday, 8 p.m. Pacific time, 5 a.m. Thursday, Central European time, broadcasting live from our Twitch and YouTube, Facebook channels, but then, of course, always available later as a podcast.
Oh, sure. Yeah, and you can just look for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe too, because more fun listening for everyone.
For more information on anything you heard here today, show notes, links to the stories are available on our website, www.twist.org. And you can also sign up for a newsletter that we promise not to send you.
I don't promise anything. There may be a surprise. We do love your feedback, though, and if there's a topic that you would like us to cover or address or a suggestion for an interview, please let us know on one of our social media accounts or send us an email. We do like those, but just put TWIS in the subject line so your email doesn't get spam filtered into the biggest of all time, boat gamma ray bursts. And we see it, but it's too bright. And so we wear our solar observing glasses, but still we miss it because there's just too much light. And the future's so bright. I got to wear shades, man.
And with our shades in place, we will look forward into the gamma ray burst and then look forward to discussing the science with you again next week. Though if you've learned anything from this show, remember,
it's all in your head. Nope, wrong one. Oopsies, soupsies.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculation.
I'm gonna turn it down. Mhm. It's the after show, everyone. Thank you for joining us for another wonderful, wonderful evening of science and dancing with the music and, dancing. Oh, Kyle Pettit, hello. Thank you for joining us. Vincent Fink, thank you for joining us. Yes, and Upside Down Google. I don't know. I can't read your name, but if I could, I would say hi. Yes, we're at the end of the show, but thank you for joining us. You caught us for the dance time. A tight 107 minutes. Yes, Fada. We did expound on things at length and probably could have been shorter, but we weren't, so that is just the way it is. And I don't know, there's definitely edits that will come out at the beginning and now at the end and also in the middle. And oh, Pamela, hello. Of course it's Pamela. Welcome. It's so good to see you. It's wonderful. Justin has run off to get coffee, probably to check on his child. He said he did not have a hard runaway time today, which is wonderful. Rod Hagland, thank you for joining. Thank you for being here, everyone. It's so wonderful. Digital Nomad, thanks for joining. Who else is there? Eric Knapp, I hear you're coming to the Portland area. Yes, and there was a Kai break in the middle of the show. And if there is further, Rachel, as editor, she can choose whether to keep the Kai break in because it's kind of an odd break. Because if she doesn't keep it in, later comments about the refrigerator throughout the show will be odd. But maybe she can remove all the comments about the refrigerator throughout the show. Might be good. Did you get coffee? 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 I can't hear you. You turn off your microphone. There you go. Yes, you have a coffee? Coffee, taka coffee. Hello?
great show. Hello.
Great show. Keeping the Kai attack. That's comedy gold. It really was. What are you saying over there? What's happening?
Pamela, why is you have a very, it's a language I don't know. Australian.
Australian. Yes, Justin. Eric, okay, so you're going to be in Portland in this area for the first weekend in May for a stamp collector's show. Yes, it's Hebrew, Pamela. Yes. Stamp collector show. I have stamps. Maybe I could bring my stamps to the stamp collector show and get people to take the stamps off my hands.
You have a stamp collection. Something I did not
do.
know.
My grandfather was a philatelist.
I'm so sorry to hear that. Maybe. I don't know.
It sounds bad, but actually it means a stamp collector.
Still sounds bad. No, that's what I thought it meant. Yeah. No, I knew what it meant. I'm just sorry to hear that. No.
Yeah, so somewhere along the way, my brother and I think I have my brother's stamps too. Maybe I'll sell his stamps too. He doesn't want them. He doesn't need them. I don't know. Anyway, I've got a bunch of stamps. They're in a corner, and there's old stamps, and I should have probably gotten rid of it when Queen Elizabeth died, but I have like a Queen Elizabeth stamp and coin thing that was, I don't know.
You don't have to get rid of it before she died. You have to get rid of it before the people who care about her have died.
Clackamas. That's great.
I think is how
Shalom. Shalom, Pamela. Pipex. That's fantastic. Clackamas is not far from where I am. Not far at all. Here in Portland, Multnomah County.
I don't have an anything collection.
The collections I have are mostly because other people collected them for me, and then I added maybe a couple of things to them, but mostly it was other people collecting them for me. So the stamps, my grandfather started and made that a thing. And so I've got a stamp collection. At one point in time, I had a spoon collection because there was like an old wooden spoon rack and some old spoons. Then people were like, oh, we'll add to your old spoons. And then I had a bunch of old spoons and had a spoon collection. But then I left it at my parents' house, and one of my brother's friends at one point in time, or somebody's friends at some point in time, like came and took the spoons away and stole them, and I don't know, sold them for meth or something.
Oh God. I occasionally have an old beer can collection that I then get rid of.
You send them out for recycling.
You send them out to get recycled. I think that's the closest thing to a collection of things.
And Pamela has grandfather's stamps and mother's spoons. It's amazing that you're able to keep those. That's incredible. So it's these old collections and these old things. What do you do with them? How do you keep them? I don't know. I like things like china and stuff, but you can use them. Like a collection of china. It's a set, but you can have a meal with it, right? You can serve food and you can all eat together and enjoy a meal. Yeah. Oh no, I was gonna ask that question, but I didn't want to.
The flood.
I'm so sorry. Yeah.
Yes. Eric Knapp points out. Yes, I do have. I guess I do have art collection. Oh. I do have. Mostly in storage right now, but I have probably 50-some paintings. Can't tell by the fact that. Oh no, I guess I do have a painting in the shop. Yeah. Don't have anything hung up on the walls here currently. Need to find this is a very old place that I'm in now that has what I thought was concrete walls, but it turns out to be some
plaster.
Some very old plaster.
Are they plaster lathe?
Yeah, where
it's like the little wood pieces and the plaster, and sometimes you hit and it goes in and the plaster crumbles, and other times you hit a nail in and it bounces back at you. Boing, boing.
Yeah, so this is the crumbly version. So I found that it is. You have to kind of treat it like a cement wall, like where you anchor things in, but then you can create holes. So I'm trying to avoid that. So I'm thinking of getting some adhesive sticky things and seeing if that can last. It doesn't. It's not how I've normally hung anything, so it's nothing heavy can really be hung that way. But we'll see. This is maybe next week. Maybe next time I will have
curtains or something. Like you could get some inexpensive IKEA type Like, make it a theater type, like some red velvet curtains behind you or something with a
So I
painting
have,
behind
I
it.
don't
Make it
think I can,
fancy.
I don't think I can show it from here, but I have orange curtains on these. There's this
That's very
ceiling to
Danish.
floor windows on this one, the next room over.
Is the sun up
And
now?
they look cool. I like them, so I got these big orange curtains, and then they even match the show. It'd be great as a backdrop. Then notice this is the south side window, and so when the sun comes up, if I haven't gotten the curtains open, the entire room is flooded with orange. To the point
Yeah.
where I'm like, if I
Is
hang
everything
out
on
in that
fire?
room, if I hang out in that room long enough, will my eyes get tired of orange? Will I stop seeing orange after a while? Like, how does that work?
Hmm.
Too much light exposure. But
I've enjoyed that before. Yeah, Marshall's really into like the hue lighting, which is like these programmable LEDs, so you can set your lighting and everything. And I've been in Kai's room where it's been all very like magenta colors, and then leaving his room, suddenly everything is green. Like, what's happening here? The complementary colors pop out in your
Vincent
vision.
Fink says, Justin, I make science art. If
You down with that for
you
your walls?
I would love to see that. Is there? Do you have a way of linking that in the chat room so people can come see your artwork?
I don't know if YouTube
love,
will allow a link. You hams what you hams.
I would love to see some science art.
Yeah, we love
The
science
image that
art,
is sitting
Vincent.
here,
We love the science art. Huge
which I
fans.
think I've shown before, is
I love this one.
so this is hard to see here in this lighting, but this is actually a
Love it.
configuration of two ancient Celtic coins. The lady, I got a lady riding a wolf here, but the wolf is the Norfolk wolf, which was found in Britain somewhere. I think it's
Norfolk.
I can't remember
Norfolk.
what age it comes from, but it's an ancient coin, Celtic coin from Norfolk. And then this lady here on top is from a Gaul coin, which I think predates it by quite a bit. But they're both
I see it.
Celtic images stolen from Celtic coins. Then I mashed together.
Totally. Oh my gosh. I just found looking on the internet, it's easy. Like the Norfolk wolf is like so obvious looking at your art. I can totally see that.
It's totally it's the
And yes, I have
inspiration
caps
for
lock on.
I don't think it can really show it here.
Celtic coin
There's the wrong
lady.
end of the wolf.
Is that gonna work? No, that didn't work at all. Celtic coin lady. Oh, there she.
So there's the horse. There she is. Yep. And
The
that's
horse.
there it is. It's the one over
cool.
one all the way on the what would be the left side there. Yeah,
this one.
That one. Yeah. And that one she's riding a horse, but I was like, yeah, let's put her on the look like she'd be more riding the Norfolk.
The Atlantic region. There it is. My general search terms: Celtic coin, woman, horse.
Yeah, very it found it right away. And there's a version of that horse that just with just the horse that I want to do one day. And it's amazing. I love the horse like it kind of looks like they had a hard time figuring out horse legs. Some of these it's not so bad. Some of them it's pretty good. And some of the Celtic coins it's like, we're gonna put some legs down here. We're not really sure. Yeah, those are pretty cool. Yeah.
Yeah. I love the three-dimensional aspect.
And you can see a lot of wheels in there. There's this. Okay, so that's a version of the horse that I'm looking at. Always has this strange netting thing back behind it, like lots of these little dots.
Serpentine horse. So it's almost a seahorse for some. Maybe, yeah. The net maybe would be like a fisherman's net or Yeah, the coin was the net design, a tented inverted triangle above the serpentine horse. Interesting. Coins of the Parisi, the region along the
And then,
Seine.
and then this one here is a sort of different,
Fascinating.
where I kind of did like this seahorsey. Of course, these don't. There's too much shine. To kind of see, but yeah. Anyway,
Got horses
I
and
also did
horses?
the if you pull up the Owl of Athena. I don't have that one here actually. I think
I remember that
gifted
one,
that
yeah.
one. But I did one that was based on the Owl of Athena.
Oh, I love that
One.
one. Ah. Look at his big eyes. Okay. I hope that your artwork came through Pamela's flood. I mean, there's some environmental things that we have no control over, right? But we can appreciate what we have from people, what we have in our world and our lives when we have them. Owl of Athena is cool. Look at his,
It's a fun one.
yeah. Alpha Epsilon, boop de boop. Greek stuff. That's cool. That's really cool art. My art is different.
You have quite. I can see you got an art collection going on back.
But
in
it's
the
nothing that
background
I've made. Yeah, but it's it's collection of Blair art and art from other people who've created stuff. But yeah. Got knitted art. I have wood print art, indigenous art from here in the Pacific Northwest. Got some fun sculptural stuff here. I think this is Magnus Apollo, who's an artist who's over in the East Coast, Midwest area. This is my great-great-grandfather's pharmacy equipment from Stockton when he had the Holden Drug Company in the 1800s. There's a bat skeleton. There's Blair art, Blair calendar, Blair art, old books. Again, grandfather, great-great-grandfather, family stuff. But yeah, I think science art and appreciating things in an artistic way allows us to better piece it into our lives, right?
Yeah.
Yeah. Oh, Pamela has a bicycle painting of yours. She likes
Yeah.
close likeness to the coin.
That is what do they call it? Penny farthing or a high wheeler. It's also the symbol of Davis, California, the city.
Oh, that's
Davis
right. The
bicycle.
bike. Yeah. Love that one.
Yeah,
I know. Yeah, this is my great-great-grandfather. So like 3 generations back. It might even be great-great-great-grandfather, actually. Like this is old school stuff. It's been around for a long time. This is this is the actual scale that was used in the pharmacy when he was a pharmacist. So it's got like weights and measures, and it's like got things for calibrating and setting it, and yeah, there's some really cool and these are microscopes, single little microscopes. Yeah, great-great-great-grandfather. Yeah. So from the Central Valley, California, outside of Stockton. From when my family, when they had a drug company there. And there's a book here, Elementary Photographic Chemistry, the Holden Drug Company, when they started actually doing the chemistry involved in photographs, right? So for making photographs into pictures. Yeah, cool stuff. This little thing is from 1919.
Wow. Free delivery.
Free delivery. It's like Amazon.
Nice.
Yeah. 1919. But yeah, the company was in my goes back a long ways.
Yeah, that sounds like that would be great grandfather territory for
That's
sure.
great grandfather. That's great great grandfather territory, but this stuff goes back further, so it's like great 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 onto the son of the sun. Everybody doing the sciences. I guess we like
Long line of sciencey people.
yeah from a long line of religiousy people before that, which I think is very fascinating. On the Beecher's side of the family, which is the Holden Drug Company, is a Beecher side. The Beecher side, uh, Henry Beecher, which is related to Harriet Beecher Stowe, but Henry Ward Beecher, was a Baptist preacher, and he used to, on the East Coast, have these big revivalist tent kind of sermons, and was like I remember my freshman year in history class, American history, and the professor started talking about my ancestor. I'm like, wait, what? And he started telling stories about my ancestor having pockets of uncut jewels that he fondled in his pockets while he gave these sermons about like austerity and having nothing. And right after that, I went to like a family reunion and I told this story to my relatives, and the old relatives in the family were so mad. They were like, who is this professor? Give me their name. How can he say such terrible things? How does he know anything? So great. Yeah. Yeah. So the Baptists, they decided to come out to the Great West. They bought a lot of land, settled a ranch. They're going to be free to do their thing. And then, oh yeah, science and pharmacy and oh, look at all this stuff. And there's like a long line of really like big thinkers in my family, which is pretty cool.
Nice.
Yeah. Family lineages and science art. More science art. All the science art. I want to support it forever. How are you? You look like you're like, I gotta go take care of a child and my needs and my spouse needs, and I haven't eaten dinner and I don't know what's happening. There's no noises in the kitchen anymore, so I don't know whether I should be afraid or fine with that.
Yeah, if I were you, I would just avoid the kitchen.
I know. I wanted to eat food. I was very excited about food when I got done with the show, and now I'm like, I don't know.
Yeah, if even the refrigerator is dangerous, it might be worth ordering.
Mm-hmm.
Yeah, a little takeout. Don't go anywhere near the kitchen. It'll be there
Just
tomorrow,
go to bed.
or
It's
it won't.
It's
but
late enough now. I can just
safety
go to bed.
first. Safety first.
Vincent Fink, I think you're right. Like I was invited in the fall to a symposium related to science and art, and a bunch of movers and shakers, like museum people who work in the museum area, in institutions and other things, like really talking about this place where science and art come together and how to advance it more, as whether it needs like its own institution, whether it needs more funding, how to support and help grow this interface between science and art so that both can develop in concert, helping each other, So yeah, I think it was called the Engage Symposium. Was it Engage?
Kiki is double checking.
Yes.
Going to the hive mind of the internet.
No, that's not right. That's African. Yeah, no, not Engage. That's not right.
Correction.
Yeah, I got that wrong. Correction. It was not Engage. It was something else. Embody. No, not Embody. That's Shotake over in Baltimore, the Embody Festival and stuff. He does like really cool stuff with art and music and science, art, and I'll figure it out. It wasn't engage. How to engage artists in science, blah, blah, blah. Why can't I remember it? I'd have to like open a whole new email account to get into it to be able to find it. I guess I can do that. I'll figure it out. I'm going to it right now. Searching my email. Art.
Boy, there's a lot of
And
stuff.
Here it is. Oh, wait. Yes. A lot of stuff. For what?
A lot of stuff in Denmark. My Google search gave me all sorts of Danishy stuff.
There's a ton, actually. Yeah, and I met some
University
people.
of Copenhagen.
Met some people who work in Cope. There was a big, big bang upstairs just now. I don't know if you heard that.
No.
I'm scared.
No. Kiki, just avoid the
I'm really scared.
avoid the kitchen.
Oh my goodness. Enfold. That's what it was. The Enfold Art Science Symposium. That was it. Dun, dun, dun. Enfold. And there is a website, and they also have a, I think Enfold Science, they might have an Instagram where they've put stuff together. But anyway,
Enfold,
it's the beginning.
EnfoldSciArt.com.
There you go. Thank you. EnfoldSciArt.com. Yeah. It was a pretty neat thing to be a part of. I was like, wow, what am I a part of? What am I supposed to do right now? I don't know. Be a part of this coolness. You're checking it out. Yay!
I gotta go.
You gotta go.
Next week. Same bat time, same bat channel, but I'm gonna be quick. I'm gonna have to be here, and then I will have to go quickly.
Okay, you'll be here, but then have to leave before 9:30,
after like an hour.
Okay, so it'll be
maybe a little bit more.
Right, yeah, because we have to start on time and then just get
We
through
have to start on time, but I gotta
you have work. You gotta catch a train.
On a train to complete my day cycle life.
Yeah, exactly, to start your day cycle.
I have to get back to the vault.
Get back to the vault.
Been in the wasteland too long. Gotta get back to the nice safe vault.
Vincent, so for this art sci thing, another place, just get in touch with me, because I do have a bunch of science art people that I know, and the science communication conference that I just helped organize and run this last week, we do have a science art component to that, and that was a big part of actually this last week's conference, was a discussion around science art and what's happening there. So I have a lot of information on at least the American landscape of art science stuff that is out there. So yeah, get in touch with me and I will be able to connect you to things if you are interested in more and figuring out where you can show your art and get more involved in the science art space / community. Love to help out with that for sure.
Thanks.
Yeah, anybody out there, not just Vincent. So just,
just Vincent. Everybody else.
Just Vincent. That's it. That's all. Anybody. Justin, you too. Anybody. I want to get. I want to help get people connected and doing the things that they love to do.
I gotta stop making art. I've got too much of it. I need to cut down on my.
No, make the art, and then you have to give me some because I don't have any of it yet.
Fair enough.
Fair enough, right? I've got Blair stuff. I don't have
Yeah, you don't have
I
any
have no
Justin
Justin
stuff? Okay.
stuff. What am I gonna do?
I'll make Justin stuff and send it
I
to you.
need Justin stuff. You don't have to make anything new, but you could. Whatever.
Well, yeah, we'll see.
T-shirts. I love T-shirts. Oh my god. Okay. No, your link didn't post because I have it probably set for the chat so that no links happen in there.
Because of reasons.
Because of
Probably.
reasons. Yeah. Because people take advantage of that kind of stuff. 0.506 for T-shirts. Vincent Fink or 0.506 for T-shirts. Awesome. Thank you. Yeah, digital art. Easier to store and move around. And if you've got it on the internets, then hopefully floods won't hurt them. But physical. I want physical things. I'm tired of the internets. I like physical things. Anyway, go do your day. Have a wonderful day, a wonderful week. You, I, and Blair. You, me, and Blair. We will talk and have conversations soon and figure out things. But in the meantime, I will look forward to next week, and even just a quick hour plus show will make me very, very happy. So, we just can't sit and talk completely. We'll just have to quick. Like I'm gonna do as I go past the kitchen. Quick. We good? Say goodbye. Say good morning.
Good morning. Say good night, Kiki.
Good night, Kiki. Good night, everyone. Thank you for joining us for another fun-filled episode of This Week in Science. So good to see you all. Thank you for joining us. Great to talk with you, Justin. So good to have a good show with you. Thank you.
Yeah.
Thank you. And everyone, have a wonderful night. Send me emails if you need to. I got the emails. Remember to use TWIS in the subject line. And we're dancing now because Justin was doing that. And stay safe, stay healthy, stay curious, and stay lucky.
Luck. You need the luck. Gotta have the luck.
See you next week for more TWIS. Pew!